Hello, welcome back to the second video on C in my little short video series. Today I'll be talking a little bit about compilers. We are going to write and run our first program. Then I'll walk a little bit through that program and tell you what it does. And then we will talk about IDEs and why I think you should be using one. Let's jump in. Okay, so we're back in my whiteboard. Let's talk a little bit about compilers. What is a compiler? Well, what is our goal here? To write a program, we want the computer to do something, right? We want to tell the computer to behave in a certain way. Well, first of all, a computer only understands zeros and ones, also known as binary, on or off. It only works that way because it's a digital computer. It's zeros and ones. That's what that means. And so it doesn't understand English, plain and simple. And so to be able to get the computer to execute commands, I somehow have to tell it those commands in zeros and ones. All right, so let's draw a little diagram here. This box is my computer. Computer. It understands zeros and ones. So if I want to have it do something, I have to send it, 0, 1, 1 0 0 1 1 1 0 0, whatever, right? That's how that works. Now, you and I can't read and write in zeros and ones. We just don't understand it, plain and simple. And so that was kind of the idea when people created low-level programming languages like assembly. Let's just Assembly technically is human readable. They use words that are more words and abbreviations that you can recognize, which then can be translated into zeros and ones. This, by the way, we call machine code. Machine code. That is a term you'll probably run into as a programmer. Machine code means zeros and ones. That's what the computer is going to run. And so, okay, we have assembly. We could write assembly, but it would take us forever. Assembly, like I said, is a very low-level programming language, which means that you have to have a pretty deep understanding about your computer and how it works, and like the architecture, the inner workings of your specific computer, or your specific operating system. So it does things like in assembly, you write things like go to this very specific place, this very specific address in memory, and write something there, and you can do bitwise operations and like bunch of very like low-level stuff that we don't really want to think about. We just want that to work under the hood. And so that's why we need a higher level programming language like C, which can then be translated into assembly, which can then be translated into machine code, zeros and ones. So that's the general workflow. You see, assembly, if you write assembly specifically, you're probably going to get a very machine-specific code. Like, if I took that code and ran it on another computer, it probably wouldn't work because you're working on a certain architecture, you're working on a certain operating system, and so that code might not work on a different computer. But that's kind of where the compiler comes in, is that from C, which is machine independent, it then can take that C code and translate it into machine specific lower level code. And that's the gist of a compiler. That's kind of how it works. There are more levels to this. Say, for example, if I have multiple files that I want to kind of combine to make one program, then that uses something called a linker. There's a pre-processing step to the compiler that goes over, like, checks your if you actually misspelled something, or as if there's a syntax error, it checks for mistakes in your code. So yeah, but that's the gist of a compiler. And now let's look at which compiler I'll use. All right, so the compiler that I'll be using in these videos is called GCC. It stands for GNU Compiler Collection. We have other options. I am working in Windows 11, and so I could be using MSVC or Clang. But, I'm using GCC for these videos. So let us open a terminal window. I'm going to be using PowerShell. So I'll open PowerShell. Now this looks a little intimidating, but it really isn't that bad. So we're going to have to know a little bit of like command line commands to do this, but I'll explain every step of the way as we're using them. Now I have installed GCC on my computer, and I kind of expect you to be able to figure that out on your own. I'm not going to be explaining how to install GCC. Just Google how to install GCC. All right, so we'll be using GCC. So if I write GCC, well, first of all, you might not be familiar with PowerShell in the terminal window. So what is this saying here? It's saying we're using PowerShell as kind of our shell language. We are in the C drive, which is my hard drive, and under this directory. So just as you would open File Explorer and go through different directories, you would go to different folders and such. A directory is just a different name for a path to a certain folder. So in my hard drive, I'm in users, and then I'm under this username. Cool. So I want to be using GCC, the GCC compiler. Okay, just let's write GCC, enter, and see what happens. Okay, something happened. It says gcc.exe, fatal error, no input files, compilation terminated. So what happened was that I tried to run the GCC compiler, and I didn't tell it what to compile, no input files. And so it just kind of terminated and stopped. I don't know what to do. I'm going to shut down. Okay, so something is right here. We could write GCC, and I'll show you a couple of different helpful commands. One, if I do -- version, enter, that tells me exactly which version of GCC that I am using. And it's saying 6.3.0. Okay, that's a little bit helpful. But so I can see that I can write GCC and then some flag, some argument afterwards. But how do I know which arguments and which flags I can set? What can I do here? Well, there's a handy one that pretty much comes with any CLI tool, and it's --help. And if I enter, it gives me a bunch of information. Lots of stuff. But the gist of this is it's telling you which flags you can set here. So say, for example, I could write GCC --help. And that displays this information, which is what it did. I can write GCC --version, which we just did, and that displays compiler version information. So this is a very helpful page. We are going to be using some of these down here in a minute. But just know that if you get stuck and you don't know what a certain flag or command was, just write gcc -- help. And you get here. If you find that this terminal window is very cluttered right now, I want to clean it up, then there's a very handy command called clear. Enter. And that just clears the window. You didn't lose anything. It just cleared this window. So if I, again, write gcc version, like, it's still there. Cool. So now we know a little bit about, we know the compiler that we're going to be using, and we know how roughly we interface with it, how we use the compiler. What we need next is our program. So let's write our first C program. And a lot of people, when they tell you how to write a programming language, will dive right into what's called an IDE. Now I'll hold on to that for a little bit, because I think this way that I'm about to do it will show you kind of why it is useful to have an IDE. So what we'll start with instead is we will just use notepad, like so. Notepad. Notepad, it's let's just start here. It's the simplest text editor that you have in Windows. And so can you really write a full-blown C program with just Notepad? And the answer is yes. So let me just write the program, and then I'll tell you what it does and walk you through it in a second. So here we go. Okay. There. That's our first program. Not a lot. It's a very small program. But the gist of it is it will try to write the text hello world to our terminal. So let us save this file as a C file. So I will save. That's Control S, or I can do file save as. And let's save this to our desktop. And I will call it hello.c. And that .c is important because you're telling, you're kind of explaining that this is C code. And also make sure to select all files here. Otherwise, Windows is just going to add .txt to the end of this, and we don't want that. So this is how you do it. Save. And ta-da! We have a little file here called hello. And if I close this for a second, and then we right-click on that file and click Properties, we can see that this is, in fact, is a C file, .c. Cool. So we wrote our first program. But, I mean, we haven't run it yet. We haven't compiled it yet. So let's do that. Let's open up PowerShell again. And I'm going to have to teach you one more thing, because right now we are in this specific directory, but we want to be in the desktop directory to be able to see this file. And so what I'll do is I'll write cd, which stands for current directory, and then I'll write desk for desktop, and then I'll hit tab, which will autocomplete my and it'll be like, is this what you meant? Yes, it is what I meant. So cd desktop, which will put me in the desktop directory. Now if I now I should be able to reach this hello.c file. Okay, what should we do next? We should compile this code from C to machine code, to zeros and ones, so that we can run it on my computer. Right? So what I'll do is GCC, and if you remembered from earlier, if I just wrote GCC and press enter, it says you didn't give me an input file. No input files. I couldn't do anything. So GCC, and then I have to tell it which file I want to compile, which is the hello file. And then I tab again, which will autocomplete and be like, oh, is this the file that you meant? Yes, it is. Hello.c. And if I press enter on this now, we got a new file. It's a little weird. It's called A for some reason. And if we hit right click on it and hit properties again, we can see that it's an .exe file. It's an application or .exe file, which means that it is an executable, which means that we can run it on this computer. This is zeros and ones. This is a file that contains zeros and ones. If I try to open this file in a notebook, for example, edit in notepad, it's just going to be gibberish. This is because zeros and ones are translated into text in a certain way, and so because these zeros and ones don't necessarily mean specific characters, it's just spitting out gibberish. Cool. Okay, so we have what can we do now? We have compiled, so now we can run. Okay, so if I write A and hit tab again, it's going to autocomplete and be like, is this the file that you mean? Yes, for sure it is. And it says a.exe. If I hit enter now, we just ran our first program. That spits out to the terminal, hello world, which is what our program was meant to do. So what have we done? We have written a C program, we have compiled it into machine code, and then we have executed or run that code on my computer through the terminal. That is the core of C programming. The rest, I mean, there's a lot more to it, of course. Like, there's a lot of other things. But this is the core. If you understand this, you have a very good foundation and a very good starting point to do software development in C. So, I told you earlier that if I jump back to my notebook here, or whiteboard, I told you that C translates into assembly and then it translates into machine code. And it does this behind the hood. And if we want to show the assembly that it does, we actually can do that. So we will just, like earlier, let's write it GCC hello, like before, but this time we want to add dash S, capital S, and I'll write that or run that, and now we got a new file up here. It also looks like the previous hello file, but if I look at the properties of this file, it now says it's an S file. S file. That is the file extension for assembly. If I open this one in Notepad, you'll see this is assembly. This is a programming language. You can see here it's saying these are the ASCII characters that we want to write, right? And so this is the text string that I'm printing to the terminal. It's talking about this global. We can see main, which is the name of something in our code. So, it's using abbreviations and words that we can recognize as humans. So, sure, we can write assembly code. But you can see that these 5 lines or whatever translate into this many lines in assembly, which then again translates into a bunch of zeros and ones, which the computer can understand. One last thing I'll tell you about what you can do with a GCC compiler. You see that it named the executable A. And that's weird. We want to give it an actual name, and so let's do that. So let's remove this. Let's write the same as before, gcc hello.c. And then we'll give it a name. So -o, and then we'll write test dot, or let's call it hello.exe. So this O here gives the output file a name, and that's a lowercase o. So if I run this, we'll get a new file that's called hello. And if we now run hello, not hello.c, hit tab again, .exe, that runs hello world. So now we have renamed it to hello instead of A. Cool. All right, so we don't need this hello, we don't need this A. This is the gist of it. Now, what does this program do? To be able to explain to you exactly what I've written here, I have to use some terms that might be a little bit advanced right now, but we'll learn more about it later. So, first, main. What is main? Main is a function, and we'll learn more about functions. But think about it this way. When I run a C program, it looks for main, and then it runs whatever is within main. So I say main, and then these curly brackets, and whatever is within those curly brackets is what our program will run. So main is kind of the starting point of any C program. Then I write print f. So f, I believe, stands for like formatted string, and so it prints a formatted string. And the string, what is a string? Well, a string is a sequence of characters, right? And so it's a piece of text, basically, right? And so it's a sequence of characters. That is a string. So a string is notated with these quotation marks, either single or double. And whatever is within those quotation marks is the string. And so we're passing this string hello world into this printf function, and that runs and that prints that text to the terminal. Printf is not part of the C programming language, but it is added to it as extra functionality through a library. And a library is basically a collection of code that someone else has written that you can import into your program and use for yourself, so you don't have to reinvent these things. So printf comes from this standard input and output library, and we include that library in this file. If I remove this file, the program will fail because it doesn't know what printf is. Okay, that is what that program does, and if that didn't make complete sense yet, we'll get more into it. Now let's talk a little bit about IDEs, or integrated developer environments, which is a fancy word for a text editor with extra features. And they are just a very helpful tool for you to develop code. Sure, you can write it in a text editor like this, but you don't get any further help with like anything. So it's very manual labor to do this here. And so the text editor, or sorry, the IDE that I'll be using for these videos is called VS Code. And it looks like this. Yeah. Let us click File, Open File. No, File, Open File. And let's go to Desktop and let's find our hello.c file. Let's open it. Wow, that looks different. Can I zoom in here? No. Okay. Control P. Hey, there we go. A little bigger for you to see. This looks different. You can see that the program that I wrote initially now has some fancy colors. This is called syntax highlighting, and it basically the IDE recognizes certain words that are known in C, like void, or what is a function, or include. Like, it knows what those are and color them accordingly. This makes it visually more easy for a human to just kind of look through very quickly and figure out what's where. Another thing that's nice here is that we can, for example, hit terminal, new terminal, and we get a terminal straight in this window, right? The terminal's right there. We don't need to open a separate terminal. So say, for example, I go to CD desktop, just like before, and then I do GCC hello.c. Oops, have I done something wrong? Yes, I have. This is a good opportunity to show what happens if you did something wrong in your program. Here it says, expected semicolon before end of curly brackets, which means, well, it tells us that I messed up and there should be a semicolon right there. If I save and try to run that again, now it worked. Now it compiled, and it's right there. It's called dot, or like it's called A now because I didn't name it like before, but and I can run it from here. A.exe. Hello world. Our program runs straight in the developer environment. Now this is just touching the tip of the iceberg of what an IDE can do. It can help you debug your program if there's something wrong. It can sometimes auto-fill, like it can just be like, is this what you're trying to write? And you can just autofill in a chunk of text that you now don't have to write manually. And so you get a lot for free when you're working in a developer environment like this. And that's the point that I wanted to drive home. That's why I showed you to begin with, here's how we can do it in Notepad. Here's why we're doing it in an IDE and why I think you should be doing it in an IDE. All right. What have we done so far? We have talked about compilers. We have talked about which compiler I'll be using, GCC. We have written and executed our first program, Hello World. We have talked a little bit about how a compiler works and like its internal workings. We've seen assembly. And finally, we've talked a little bit about IDEs, integrated developer environments. That's a wrap, I think, for this video. In the next video, we'll start looking more into the language C now that we have the tools to program in C.